Here we are with 2016, both Calculus A, B, and BC, question number 1. I've already pre-written some things that should be highlighted. So water pumped into a tank, it's a rate, and it's WT. I already put that in my calculator as Y1, but I stated what WT is on top. And then we read water removed at a rate R of t. So here I say R of t is the rate out, but also important information. R is differentiable and decreasing. So I wrote those two things here. That looks like deleting, decreasing. So it's important to annotate, just pull out important information. That way it's kind of in your brain. It's in there. You're going to remember it better, and you don't have to reread your question again. And the last thing, at time t equals 0, there's 50,000 liters of water in a tank. That's the starting amount of water. So often in these problems on accumulation type, you're going to have the amount of water formula. So therefore, I defined a new function a of t being the amount of water. And since the starting amount was 50,000, I said let a of 0 equal 50,000, or I just stated that. So part A, I'm going to do part A over here. We want to estimate r prime of 2. So if we look at our graph here, or our table, we don't have the derivative at 2. We don't have anything at 2. We don't have the r at 2. How do we get the derivative? I'm going to draw a graph. I've done this every time we've done this. You should realize that this is a common question. So suppose I have the value of these few points here. And I'm not actually graphing this graph. I'm just graphing a graph. So suppose you have that. And suppose we want the derivative right there at that red dot. Well, what is the derivative? It's the slope of a tangent line. So it would be the slope of the line tangent at that point. It would be that. Well, how do I find that? I don't have any of that information. I don't know the equation of the blue line. I don't know. So the logical thing to do is to take the slope of those 2 points around that, and that will approximate the slope. So that's all we're going to do. It doesn't take much space, so I'm going to do it on the bottom left here. So the 2 points around 2 would be 3 and 6. So it's going to be r prime of 2 is about r of 6 minus r of 3 over 6 minus 3, which is, I just plug in the values, 740 minus 950 over 3. Now here's the thing, they want units of measure. Well, R's are liters per hour, and T is hours. So I'm going to put liters per hour over hours. You can leave it in that form. You should not simplify. I mean, since you have a calculator, I guess this is less risky, but it's a waste of time. This answer is fine. Now, if you simplify your units, it would be liters per hour squared. But you could leave it liters per hour. That's fine. All right, part B. use the left Riemann sum with 4 subintervals indicated. By the table to estimate the total amount of water removed from the tank. Is this an overestimate or underestimate? So I'm going to do this up here. I know it's going backwards, kind of upside down. So how do you get the amount of water removed? You integrate the rate of water removed over your time period from 0 to 8. And we're going to use a left Riemann. So I'm going to write my intervals here, or circle my intervals. The first interval is 0 to 1. So if I want a left Riemann, the left-hand side is clearly 0. So the height of this will be r of 0, and the width would be 1. My next subinterval, 1 to 3. What's the left side? Clearly it's 1. So it's r of 1, and the width of that is 2. The next subinterval is 3 to 6. The left-hand side of that is clearly 3. So the height at that point is r of 3, and the width is 3. And then my last interval will be 6 to 8. And the left-hand side of that is clearly 6. So the height there is r of 6, and the width is 2. At this point, I plug everything in. It's going to be 1340, 1190, 950, and 740. So that's the left Riemann sum. Let me reread the question. Left, 4 subintervals, estimate the total amount of water removed in the tank. So I did that. That is the answer. We'll box it so you can see the answer. But it asks us for more information. Is this an over or underestimate? So I'm going to draw and let you understand this. Let me get rid of these things. So is it over or under? What tells us that? There's 2 properties that often deal with over or under. Concavity and increasing, decreasing. So I'm going to show you why concavity doesn't matter. If it's concave down and we're doing left Riemanns, we're going to do a bunch of rectangles on the left side. So if I draw a rectangle here, the left side will touch there. If I draw another rectangle, the left side will touch there. Now it looks like these are under, right? But if I do a left hand over here, whoa, I don't know what just happened. A left hand over here, look at what starts happening. The left hand Riemanns over here are too big. They go over the line. So concavity doesn't tell you that. But if you look, when it's increasing, it's under. When it's decreasing, I have over. I have too much. Can I make these hollow? I think so. Uh-oh, that's not what's supposed to happen, but oh well, it works. It works. There's probably something else I could have done. So it's increasing, decreasing that gives it, not concavity. So what do we know? Oh no, is this function increasing or decreasing? Well, if you annotated, you probably remember it told you it's decreasing. And on a decreasing portion, it's an overestimate. So you can say this would be an overestimate. And why is it an overestimate? The justification, because R of t is decreasing. Done. That's B. All right, let's go to part C. Let's read this. So we're going to use our answer from part B to find an estimate for a total amount of water in the tank. So we already defined a function on top. That was my alarm to wake up, but I'm already up. So part C, to find the total amount of water in the tank, it's the starting amount plus the amount added. So to figure out the amount added, you would integrate the rate water was added from 0 to t. And since t is used up as a variable, I will use x here. And you subtract the amount of water removed. That would be the integral of r of t. But since I used t already right there, I have to use a different variable. And x is good because my calculator uses x's. So we want the amount of water at 8. So that's a of 8 will be a of 0 plus the integral from 0 to 8. That will have to be done on my calculator. And the integral from 0 to t of r of x, not r of t, 0 to 8 of r of x dx, that's the amount of water removed. So a of 8 will be the starting amount, which we found on top here, 50,000. This integral, I'm going to pop in my calculator right now. So you're going to do math 9 and 0 to 8 for my limits of my integration. I'm going to go alpha trace to get my y1 dx. And when you pop that in, you get an approximation. You get that. And then this answer, okay, let me show you something. All of this can be written right here. So you can write that whole thing over again, or if you just punch that in your calculator to make your life a little bit easier, you get 8,050. So you would put 8,050 here. And, ooh, we could, my first thought was that's your answer, we're done. But to the nearest liter, that's why you need to reread questions. I would have messed up. So if you add this on your calculator, I'll get another squiggly equals. You add that up and round off, you get 49,786 liters. There's our answer. Let's go to part D. This is the hard question. This is the one that a lot of people struggle with. And so is there a time at which the rate of water which is pumped into the tank is the same as the rate of water, the rate at which water is removed from the tank? Explain why or why not. So the difficulty here is we have specific R of T's. And we don't have the value of R between those. But what we do have is R is continuous and decreasing. We know that. So we know it's continuous. So the tough part is this is given in a table. W of t is given in a function. So how do we deal with the two? So basically what's happening here, we got to use a couple things. And I'm just going to explain what the solutions has and why that works. So they want to find W0 and R of 0 and compare. So if you do that, you pop that in your calculator. You know what? I'm going to find the actual value. You'd have to just go test each point. 0, 1, 3, 6, 8. So W of 0 minus R of 0. I can do that in my calculator. So I'm going to pop that in. So how do you get W0? I'm going to go alpha trace Y1 at 0. So I put parentheses 0, 0. And then R of 0 is 1340. So I'm going to minus 1340. My calculator gives me an answer of 660. So we know that W0 is greater than R of 0 at that point. Now we could continue doing that on all the points down. So let me do this at 1 now. And we have 1190. Oh, it's positive still. So let's continue. I'm going to jump all the way down. And we don't necessarily have to go do every value. What we're going to do is we're looking for a point where it's negative, and I'll explain why we want to do that. So W8 minus R of 8, I will do that. Alpha trace Y1 at 8 minus 700, that's R of 8, negative 618.475. Now, there may be a point earlier where it became negative. I don't know, but you could test point by point. So what's happening? From the first one, we know W is bigger than R. Here, we know W is less than R. I'll do squiggly. So that means at some point between here and here, W minus R must equal 0. That's intermediate value theorem. For that to work, it must be continuous. So a lot more work we need to do here. So this is an exponential function. We know exponential functions are continuous. So W of t is continuous. Now, is R of t continuous? Well, R of t is differentiable, so we can get continuity from that. So if it's continuous, the mean value theorem must apply. This is the hard problem. This is a crazy one. So what I want to say, since R of t is differentiable, therefore R of t is continuous. Therefore, W of t minus R of t is continuous. So we have continuity, and we have one endpoint positive and one endpoint negative. So check this out. W0 minus R of 0 is greater than 0 is greater than W8 minus R of 8. So here's the logic. It's positive here, negative over here. So if a function goes from a positive value to a negative value, it has to cross 0. That's the intermediate value theorem. Therefore, there must be a time t. So here's what we're going to do. Is there a time t from 0 to 8? Therefore, for time between 0 and 8, there is a time t. I'm just copying this. For 0 to 8, instead of there is a time t where W of t minus R of t equals 0. because again, here it's positive, here it's negative. So since 0 is between these, it has to cross 0. Therefore, W of t must equal R of t. I just add R to the other side. So we have proven there's that time. So that's it for this problem. I know D was crazy. That was only worth 2 points in the big scheme of things. So not a whole lot, but hopefully it made sense. But if you struggled, understandable. A lot of people did, but hopefully conceptually you just understood what happened. All right, that's it.